All right. Thank you for joining me. We have a very, very dangerous situation right now occurring. We have right near KEVX. We have a supercell. No tornado right now, but it's having a handoff where the old couplet is taken over. So see, there was this couplet here is now so you're having some rotation embedded inside the cell as well, right in here. So, and we're also having a problem near Mobile as well. Oh my God. Oh God. I mean, it is moving further away from the radar site. Gulfport, southern portions of Gulfport are about to be hit by a tornado, or at least a possible supercell. Possible tornado. Let's see which one is closer. 3,000. So, okay, looks like a KLAX is closer. Yep, definitely got a pretty strong couplet with that. So we're having VROTs. Oh my God. This is bad. This is really bad. We have a tornado heading towards Gulfport, Mississippi right now. Possible tornado. Tornadic water spout about to come ashore just near Gulfport, Mississippi, south of Long Beach. It's moving northeast, and if this continues in its present course, it will impact Biloxi and Delberville, and then St. Martin, Gulf Hills, and Ocean Springs. All these areas are in the path of this very dangerous supercell, or dangerous embedded supercell. It's actually along a line, and here we're having the discrete cells. Yeah, and here are more discrete cells coming northeastward. Come on, issue the warning. It's about to come ashore. Come on, National Weather Service in Biloxi. Do your thing. Or Mobile. National Weather Service Biloxi. All right. Yeah, this is bad. It's definitely like it's like in fact it's getting closer, and yet it's intensifying. It's really bad. Oh, radar hole. Oh no, 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 no. That means the rotation is so intense that the radar can't pick it up. There's no tornado warning. This is the old warning. It's expiring now. See, expiring in 1 minute. They need to issue a new warning. Come on. You know what? I'm calling National Weather Service. Wait, what? Okay, I think that's confirmed. Um, hold on. I think there's a problem with radar scope. Let me go on my phone. Ready? Nope, they issued a new warning. Finally. Okay, radar indicator rotation. Okay, at least they issued a warning. That's good. But that is really, really strong. That is 104 touching or near. Yeah. So there's definitely rotation. This is bad. This is really bad. Gulfport is literally, southeastern portions of Gulfport are getting hit by a tornado right now. Please, I don't want to see any blue. No blue. Please let there be no CC drop. Oops. I said the wrong one. Please be wrong. Please be wrong. Okay. It's about like 11 miles an hour. Okay, I'm not sure if that's actually accurate. I'm gonna go to KLIX just to make sure. This is like, I want to get another confirmation. No, that is pretty accurate. That is the fact that we're getting a cooperation. We're having 100 touching 25. So that's 125 right there. Oh, God. That's an average VROT of 62.5. Yeah. Oh! Oh! Oh, God. It just went right in our hole. Okay. Not good. That's bad. It's still on the water. It's still over water. Yeah, it's still over the water. It's about to come ashore. Oh yeah, that's strong. That is definitely strong. Let's see what KMOB is showing. Oh God. Okay, it's weakening a little bit. It is literally paralleling the beach. It is literally like if you were on the beach and you were looking out, you would probably see a massive wall cloud or even a couplet right now, or probably probably a wedge water spout. Maybe not the condensation funnel on the water, but you would see like what happened off of Fort Lauderdale back in 2010, 2013. There was a water spout that went off Fort Lauderdale. It was like paralleling the beach, basically. This is what's probably happening here. And it's entirely wrapped in precipitation. In fact, to the naked eye, you probably wouldn't think much of it. I mean, you would think, oh, it's just some heavy rain, maybe a little bit of rotation. But when you look at the velocity, you would probably be spitting coffee out of your mouth. Yeah, this is bad. I mean, look how much inflow is going into this storm. Look at its inflow. I mean, look at this inflow. It is literally sucking all this moisture in. Look at this massive inflow notch going into the storm. I mean, this is an embedded supercell in this line of storms. Okay, it's coming ashore, guys. It's coming ashore any moment, like 2-3 minutes. It is coming ashore. The location that is impacted by this tornado. This location is between Gulfport and Biloxi. So this is going to be near Mississippi City. This is basically by Mississippi City, east of Gulfport. Yep. Here's Biloxi. Yep, Mississippi City is right here. So this is making landfall just on the eastern side of Gulfport. Just east of Gulfport, near Edgewater Mall, IHOP. El Saltillo, Mexican. This is Biloxi, so it's going to be coming ashore in the western part of Biloxi. So the state, the Gulfport City line. So the Gulfport city limits extends out to near Big Lake. So this is Big Lake right here. So this is all Biloxi here. So this is coming ashore right on the western part of Biloxi, right along the boardwalk, near the Jefferson Davis Presidential Library. Before Biloxi, Mississippi. Library Pavilion, Beach Boulevard. So impacted is the Hookah Up Cafe, El Rancho, Pass Road. So all these areas are impacted by this potential tornado. Until I see any confirmation on radar, I will not confirm because, I don't want to start panic. So, but treat this as if a tornado is on the ground and be underground now. But we are likely having a tornado on the ground. Okay. Wait. Is that a TDS? Hold on. Okay, not a TDS. Okay. Yeah, looks like the rotation is handing off. Yeah, it is weakening a little bit. Yeah, it is weakening a little bit. But something is still going on here. So basically what is going on is it's recycling. It is cycling right now. The current couplet is weakening and now a new area of rotation is taken over. It is currently going through a mesocyclone replacement cycle. So you know how hurricanes have an IWO replacement cycle? In supercell thunderstorms, you also get replacements of mesos, especially in very, very strong supercells. It is possible that the same meso can, be producing the same tornado for 100 miles, like what happened in Mayfield. But that's like very, very much so the exception to the rule. Usually tornadoes, like hurricanes, go through replacements, IWO replacement, and mesocyclone replacement cycles. Like where one meso dies, another one takes over. Of course, it's not the same thing, but it's similar in terms of processes. Okay, no debris. Let's see. That is off the coast. Velocity. Okay. Okay, the meso has come ashore. No debris. Thank God. Okay. Okay, that looks like some sort of radar spike. Not debris fallout. Okay, that's good. Okay, we have several tornado warnings still. We have 4 tornado warnings. One for Choctaw and Clark counties in Alabama. Another one for Crenshaw County in Alabama. Franklin and Gulf County is in Florida. And Washington County is in Florida. Nothing for Mississippi. Everything is Alabama now. Yeah, so I think we have one in Mississippi, right? Oh yeah, Mississippi, right? Down here. Okay, radar indicator rotation. Looks like we're having a new cell coming ashore. Correlation coefficient. Okay, radar indicator for now. KEOX. Wow, that is very intense. 2000. Okay, let's go to tilt 4. Okay, let's go to tilt 2. Tilt 3. Okay, so nothing above 55. Okay, that's good. Okay, let's go to tilt 2 here. Tilt 1. Whoa! That happened at... That's bad. Okay. Tilt 3. Okay, let's go to tilt 2 now. Okay, I'm going to look at a different radar. Let's look at simulated echo tops. Or enhanced echo tops. $46,000 feet. KMOB is showing, and hence echo tops about, again, 48,000 feet. That is very, very high. Let's look at the reflectivities of the surface. That is definitely trying to form. Come on. Yep. Oh, yep, that is definitely rotating. I mean, some of these storms might actually be, I think they are surface-based, but they are in the shield of stratiform rain. But you could still get tornadoes in stratiform rain. I mean, we've seen it before. We saw it in Florida during a hurricane. So, just because it doesn't seem probable, it's still likely. In fact, rain can actually stabilize the mid layers, which could actually cause stronger RFD winds. But it could also be a detriment too. So this is the cell that has the really, really high echo tops. We were looking at KMOB, and now they issued a new warning. Brand new warning for that storm that just blew up like crazy. See, 46 minutes, radar indicated rotation. The echo tops of this cell are incredible. Still, no tornado yet. No correlation coefficient drop, so that's good. There's no hail with this, so wait. That's probably, no, I don't think that's related. Yeah. The closest radar site here is They really need to plug up these radar holes. It's KMOB. 25 miles, but 10 in here. We need a radar site here too. Western Alabama needs a radar site. Like central Western Alabama needs a radar site, especially with all these towns here. I mean, you have Demopolis, you have Forkland, you have small towns. I mean, they're just as important too. Okay, yeah, I'm not believing that. 140? Come on. Like, really? You really think there's 140 knots winds in there? Especially since the winds are so weak on the backside? I mean, it's possible, but... I mean, you never know. I mean, the tops are up to 50,000 feet with this. Over 50,000. But some of this stratiform rain could be impacting the velocities a little bit. I think it's more likely probably 50 touching 50. And that's a loft. It's not at the surface, so... Need something closer. Too far. Second closer, I think it's KBMX. So it is showing rotation all the way up to like 16,000 feet. So this whole storm is definitely rotating. I mean, if this works its way down to the surface, this is going to be a really strong tornado. 18,000 feet. Wow. Yeah, KOB is as the closest radar site to this. I mean, it's crossing a road. That's McIntosh. Righty. Let's go back to KTLH. Look at the surface. Reflectivity. Storm is still intensifying. I mean, it's still... I think it pulsed already. I think it kind of hit its maximum height already. And no, it did not hit its maximum height already. One, 55? Are you kidding me? Oh my lord. Oh my god. Oh my god. Oh god. Yeah, I know I'm using beam height. I need to be using enhanced echo tops too, but Jesus. This thing is blowing up. Yeah, it's time to use enhanced echo tops here. Oh my god. Let me see. That's 1, 2, 3. 1, 2. Okay. It's about 52,000 feet. 52,000 feet. We have 52,000 foot echo tops, guys. Oh my god. Yep. 52,000 feet. Actually around 53,000. I'm just averaging it out. It's around 53,000. Yeah, this is going major. God. It's not 50. Wait, I think that is 53. Still no CC drop. It could be that the storm is not surface based, but like slightly elevated. Considering there's no, maybe there's not enough helicity at the surface. Or it could be something else. Maybe there is enough helicity on the surface. Maybe the RFD is not strong enough. I mean, the rotation is weakening right now. Yeah, seems kind of in a line. I think if you had no precipitation, like if you didn't have this stratiform rain, the storm would have been a freaking ape. It would have gone ape crazy. It would have gone completely bonkers. But I think we got that stratiform rain to thank for the lack of violent long track tornadoes. Like, literally thank the rain for why we're not having tornado after tornado dropping right now. But here, and also it's organized in line segments, so they're not totally discrete. Like, you're not having a storm with nothing around it. You are having rain embedded in this. But still, this is a discrete storm. This is semi-discrete. Like, some of these storms here are totally discrete. Like, there's some totally discrete storms here. This is more of a semi-discrete. I think what is going on is, on the surface, you're having some stability from the rain. But then the atmosphere becomes more unstable as you go up. Or there's instability at the surface, but then it stabilizes as you go up. And then it becomes unstable again. So it could be that mid-level stable air that's kind of inhibiting that tornado, because maybe where you're supposed to have all that dry air in the mid-levels that will enhance the RFD, it's very moist up there. So that's kind of preventing the RFD from really taking over and dropping that to the surface. But you never know. I mean, it could still form, but I think what you're lacking is the RFD. And that's good, because you don't want a tornado. This is actually the best case scenario. No tornado. This is actually good. You're having a really strong thunderstorm that's tornado warned, but no actual tornado. However, here, I am concerned about these storms here. I mean, see, they're rotating and they're moving northeastward. And there is no stable air. I mean, there is no rain here. There is no stratiform rain. You're having nothing. Clear skies. So very unstable air. Much more unstable than here. But maybe not as much helicity. So what is going on right now is, as this progresses eastward and you have more of that forcing, you'll have more discrete storms forming in ahead, but the helicity will decrease. But you'll still have a higher chance of spin-up tornadoes because you're having discrete storms. And you will have more a chance of rear flank downdraft. As the air in the mid-levels is dry, and as air cools and condenses, because, dry air, if you add moisture to it, lower dew points. As the air becomes more moist, the surface temperature and the dew point will try to meet together to reach equilibrium, which means the dew point will increase while the surface temperature will decrease. And that will mean the air will be cooler and it will descend and form the RFD from the mid-levels. And that is how you get tornadoes. But if you're having a moist mid-level, where the humidity is greater than 70%, you won't have that much cooling, and so your RFD won't be very strong. You don't always need a strong RFD to form a tornado. Sometimes you could get a tornado to form just from wind shear alone. But RFD is very important in tornado genesis, because what an RFD does is it brings that rotation that's aloft down to the surface. But it can also choke off the tornado too if it becomes too strong. If a supercellular thunderstorm becomes RFD dominated, it chokes itself. it basically, literally grabs its hand around its neck and it chokes itself, cuts its flow of moisture into the storm until a new area of rotation forms, most likely to the northeast of the RFD, of the cutoff circulation. Because it's trying to bring in that warm air that's in ahead of the RFD or of the cooler rain-free, out of the head of the rain-cooled air. Now talk about the surface. I mean, you have the helicity. You definitely have enough wind shear for tornadoes. But the reason you're not getting touchdowns is because you're not having strong enough RFDs. However, these storms, I'm really concerned about these ones here. I mean, they're probably producing some water spouts. There's not every single one of them, but probably a couple of them are definitely producing water spouts. This one has a hail core. So, and this is moving northeastern Florida, so yeah, we might get some tornadoes tonight near between Pensacola and Santa Rosa Beach as this moves, all this stuff moves northeastward. Yeah, so plus we got a tornado warning here. Yeah, that's a bit of a line segment here. A little bit of a Boeing segment. And it's severe warned. Good call by the National Weather Service. Definitely going to have some pretty strong winds with that. Yeah, definitely gusting out here. Oh, the little area of rotation there, a little supercell there. Okay. Alrighty, let's look back at the Mobile storm. Might have got a little spin up there. Yep, a little possible spin up. Okay, good. No CC drop there. We have 3 tornado warnings. Thankfully, no tornado on the ground as of yet. But I don't want to go away and then, tornado just tries to form behind my back. I want to make sure everyone is safe. That could have been a little spin up there. Yep. We definitely just had a potential spin up. Yep. No. Hold on. Okay, 706. Okay. Yeah, that's definitely intensifying. And that's about to cross. Okay, that's about to cross Chatham. Let me see what that is. Chatham, Alabama. So it's about to cross that. A couplet is about to cross St. Stephen's Avenue or Highway 56. Yep. Yeah, it's just east of Chatham right now. So it's Washington County. Yep. Yep. For Central Washington and Central Clark counties. Yep. So looks like it just weakened. Thank God. Yep. No correlation coefficient drop. Make sure that is not having rotate. Oh, wait. Okay, false alarm. That's just a radar spike. Okay. Nope, no rotation there. Okay, that's just the radar beam coming from the KMOB radar. Okay, that's just the radar spike. Okay, so not rotation. Good. All right. So okay, still tornado warning. Okay, that's your your Boeing segment. The tornado warning storm is here now. I think that warning, yeah, it expired. Good. We don't need a tornado warning that is not gonna from a storm that's not gonna produce. That's just gonna KEOX. All right. This actually has potential because it is in a very stable, unstable environment. No rain cold air ahead of it. Problem is all your helicities back here, but all your instabilities here. But if this was stacked one on top of another, it would have been like this morning, but worse. Okay. Thanks. Family, thank you. All right. Mobile right now. Weak rotation. Still could spin up though. It's really trying to. I mean, it's basically kind of a embedded supercell combining into a MCV, basically mesoscale convective vortex now. You're having some embedded like eddies in that line. Here you're having all the discrete cells here. So you're having a semi-discrete mode right now. Definitely semi-discrete in this area. You got special marine warnings here. Based on what I'm seeing with velocity, it's probably wind and it's wind driven here. This is a wind driven special marine warning. Wind and maybe rotation, like water spouts. I mean, yeah, water spout, wind, and a small hail. See, water spout possible, yeah. Almost all your special marine warnings today are mostly water spout driven. Like this is water spout driven. Yeah, water spout possible and wind. Same here, water spout and wind. See, wind's 40 knots. Probably for, yeah, wind gusts. Yeah, that's why they put that slight risk for wind, because they knew there's going to be a wind threat. Okay, special marine warning. Yeah, actually they're issuing a very broad warning, but I think they should also issue like a one for this cell, because this is a discrete storm. This is a discrete cell in the head of the line here. The cell doesn't look impressive. Like, okay, it just looks like a regular thunderstorm, not too severe. But it's rotating, guys. It's definitely having rotation. Because every updraft today is rotating. I mean, helicity today is very high. There's a lot of rotation. Every updraft is being tilted upward. So you're having that rolling motion that's being tilted vertically, and that rolling motion becomes the spinning motion. Yep. That's what's going on today. So now I'm going to change gears and look at the models. But I am going to go back to the severe threat in just a moment. I have to go to bed early tomorrow, so I am going to be ending the stream at around 10. Okay, so it looks like New York City is going to be getting rain. Yeah, this is going to be a rain event. I wonder what that is. That's not a tropical system. What they're showing is basically a coastal storm. See, they're showing a storm forming, right? This is basically a coastal system, like a kind of like a nor'easter that's forming along this line here. So a lot of cold for the Northeast, but I don't see any snow for New York City. Oh yeah, this is just going to be brutal cold. Temperatures at the surface are going to be in the teens and 20s. Teens and 20s for highs, single digits for lows in the city. Probably some like low teens for highs. Within PA being probably single digits, maybe some sub-zero lows. Yeah, there we go. Here's basically what I'm thinking. The reason it's not going to be as cold as here is because the Appalachian Mountains and the Great Lakes warms it up a little. Because here you're having some, see, it's warmer here. You're having some warm air here. The Great Lakes kind of warms up the air a little bit. Then the downslope effect of the Appalachian warms it up as well a little bit too. See? See how the air warms as it goes closer to the coast? It's not because of the water why New York City is usually so warm, why the coastal region is so warm. It is, believe it or not, it's because of the, or what they call the Chinook winds. Basically, it is the downslope effect. As an air particle cools, it warms up. Air particle rises, it cools. When warm air rises, it cools. When cold air sinks, it warms. That is why it is always colder in the valleys. You think, okay, warm air warms as cold air warms as it rises, but as the cold air pools into the valley, it can't sink any further. So that's why the valleys are so cold. Like, it might be colder at the very top of the mountain, but cold air also pools at the bottom. Of course, if it goes sinks, it warms up because of air pressure. That is why if you go to the center of the planet, it's so warm, because of all the pressure. It's basically how the atmosphere works. It's basically all about atmospheric fluidity. The atmosphere is basically a fluid with different layers. That's why the first atmospheric model was a fluid model. So basically, for some insects, to them, the air is basically like a goo. It's like water. Because compared to their mass, they have to push air molecules that are slightly bigger in compared to us based on their size. While to us, the atmosphere is basically water, there is still resistance, and that resistance we feel as wind. Water is just a different form of matter. Atmosphere is also a form of matter. It's definitely matter. Even though you can't see it, you could still feel it and interact with it through breathing. Anyway, moving back to snowfall, let's look at snowfall. This is what I wanted to show you guys, and then going back to the weather. Yeah. So this here is ocean effect snow from cold air, passing over the warm ocean. But New York City itself is not really going to get any. So that's based on the 18Z run. But all of the other models are showing the same thing too. So yeah, this is basically a clipper system right here. Yeah, here's a clipper system. A hybrid clipper / Pacific system. Basically, clipper systems happen when you have a very positive PNA. Storms go up and then come down. In order to have clipper systems, you need to have a positive PNA. You need a positive Pacific North American pattern to have clipper systems. Yep, there we go. That's a clipper system. That's a clipper right there. Here comes the positive PNA. Clipper system. Clipper system. Yep, we're going to have our first clippers of the season now, as the PNA is going to go positive. Yep. That's a clipper system right there. So there is a potential for a coastal storm. There is. Around hour 198. Let's see what the 12Z is saying. So there definitely is potential for something major around that time. The Euro, I didn't really check because I was kind of so focused on the severe weather. Whoa, yeah. So there's definitely potential for something major, but looks like it's going to be a pretty warm event. I was kind of like, I only saw a little bit of it, and I was like, yeah, it's going to be a warm system. It's going to be rain for New York. Yeah. So I think that's probably what's going to happen. Yep. Looks like it's going to be rain for New York City, quickly ending as the cold air comes in. Like, it's going to stop. Like, the moment the rain stops, you're going to have a cold front, and it might end as a tiny bit of snow, maybe a tiny bit, as the cold air comes crashing in on the backside. But I don't think it's going to be a lot. I mean, we could get a major storm. I mean, look how far out this is. So, I mean, if this is going to be just a little bit different, such as the 540 height is going to be a little bit further south, and this system forms the way it does. I mean, we could get a pretty major storm. I mean, this is definitely blocking type pattern storm. So, let's see how much snow New York City is going to get. I don't think it's going to get much at all. Yeah, it looks like it's going to be an inland event. Typical La Nina. Well, yeah, typical La Nina for this time of year. I mean, looks like January will probably be pretty stormy. Let's go back to radar scope now. Alrighty. One tornado warning for Jackson. Alright, guys. I'm going to go grocery shopping. I'm going to leave the radar loop running. I have to get groceries because I have literally nothing in my fridge right now. I have to go shopping with my family. I am leaving the live stream running because this is a very dangerous situation. You know, I don't want a tornado to touch down. I will be commenting. I will be monitoring the stream from my phone. So, yeah, and I need water. I need water. I have no water in my house. Ugh. So yeah, I definitely need to get some groceries. And I'm also running on fumes. I only got 3 hours of sleep last night. Okay, go back to radar scope. New tornado warning just got issued. Yeah. There we go. New tornado warning. Radar indicator rotation. Let's go to KMOB because it's the closest one. Okay. Radar indicator rotation. Looks a little strong, but it's not a supercell. It's an embedded area. Yeah, it's an embedded supercell in the shield of rain. So there's definitely some semi-discrete storms in here. But it's in a shield of stratiform rain. You can almost see it like almost trying to sag southward. But this is not the cold front itself. The cold front itself, if you believe it or not, this is the cold front here. See that little line that you're seeing? Looks so weak. That's actually the cold front itself. The cold front just went through New Orleans. See how it forms this line, this little convective line? That is your cold front, guys. This is actually your cold front right here. It just moved through Wiggins and is about to move through McLean and Beaumont. This is literally your cold front right here. It is pushing through east central Mississippi right now. So here's your cold front right here. It's just about to move through Waynesboro. Cold front is moving through. So basically from Waynesboro westward, your severe threat is over. Like, it is done. I mean, you might still get a few rumbles of thunder from some of this activity back here, but your severe threat is over, done, kaput, it's done. This is not the cold front. These are just storms that are forming and ahead of the cold front. So here is the cold front right here. This is your cold front right here. This is your cold front right here. It is finally moving very so slowly eastward. This is your cold front, guys, right here. Let's see if it's accurate. Yeah, close enough. Yeah, there's the cold front right there. See the line I just drew? Yeah. Yeah, there's your cold front right here. This is basically what it looks like. Yeah, it's basically your cold front. And of course then it occludes up in the Midwest, forming a major blizzard. Okay, So this is just residual showers here, because there's still some instability in the upper level, because a cold front sometimes doesn't cross the entire levels. Sometimes it goes from the surface upward, kind of like this. Like the cold front would pass through here while this is higher up, so the cold front sometimes would be like this, or more like this is how a cold front would pass through at the surface, like kind of like that. Maybe not exactly, but from what I learned in my meteorology class, sometimes you'll get some veering or even backing winds, which means that the cold front might not clear through at all altitudes, and this could just be some of that. Maybe a cold air trying to move through a loft as well, while it has throughout the surface. That's why sometimes a cold front might pass through. You would think, okay, we're about to get snow, but instead you're getting mixed precipitation, or you would get an inversion layer while it's cooling off as you go up, but then it would warm up, and you would be getting freezing rain. Like the Midwest, the Great Plains very often gets freezing rain events where it could be in the 20s at the surface, but you're getting freezing rain after a cold front has passed through. That's why, because you would get, not all layers have actually cooled down from that cold front. That's surface based. Sometimes the cold front would be kind of like slanted as it passes through, or sometimes the cold front might actually pass above you on the surface before it works its way down to the surface. Cold fronts don't always pass by as one swoop, like that. It's different layers. So anyway, I'm going to be going shopping right now. We have still 2 tornado warnings. And you still got hours, even like into the afternoon until this passes. Okay, tornado warning here. KTLH. Anyway, I'm going shopping right now. I'm going to leave this radar loop running. In the meantime, please check out David Schlodhauer. He's really good. Him and his team are doing a great job covering this tornado outbreak. I'm just trying to get my channel out there. The reason I'm doing this is because I am a meteorology student and I'm trying to become a weather forecaster as both a hobby and a career. Thank you for watching. Thank you for all your support. Please stay safe. I'm not ending the stream because I'm going to be back. Actually, I am. Because I'm ending the stream because, it's better if I stream when there's something actually going on rather than taken away from other people. Thank you for watching.